Let us take two forces P and Q. Represented by the adjacent side of a parallelogram. As the opposite side of parallelogram are equal and parallel, so this force must also be Q. Now, by parallelogram law of forces, the resultant R is given by R equal to P plus Q. R equal to P plus Q. Let's recall that A dot A or A dot A equal to magnitude of A into magnitude of A into cos theta, where theta is the angle between A and A. But angle between A and A is 0 degree and magnitude of A can just be written as A. So we have got this equal to A times cos 0 degree. That is equal to A square. Let's apply this idea. Once again, let's write R equal to P plus Q. That's by parallelogram law of forces. Again, let's write R equal to P plus Q and take dot product. So we have equation 1, R equal to P plus Q, and also equation 2, R equal to P plus Q. Let's take dot product to get R equal dot R equal to P plus Q dot P plus Q. However, dot product is distributed. That means we can distribute this bracket and write P dot P plus Q. P dot P plus Q. Plus, we are distributing dot product over addition, Q dot P plus Q. That's equal to P dot P. If you distribute it once again, you will have P dot P And as we have shown, a dot a equal to a square, so p dot p must be equal to p square plus p dot q plus q dot p plus q dot q. Oh, q dot q is q square. Let's write it in the next line. So this is equal to p square. However, in case of dot product, a dot b is same as b dot a. So p dot q is same as q dot p. Let's combine it and we just write it as this is 2 times p dot q plus q dot q is q square. And lastly, r dot r is r square. So if you know the magnitude of p, and if you know the magnitude of q, and lastly p dot q, okay, we can compute p dot q as well. So that is p square as it is plus q square as it is, that we know, plus 2 times p dot q is magnitude of p, magnitude of q into cos theta. Once again, if you know small p, that is magnitude of p, if you know small q, that is magnitude of q, and if you know the angle between p and q, then you can compute the resultant. So this formula says, if you know the magnitude of first vector and if you know the magnitude of second vector and if you know the angle between those two vectors, then you can determine the resultant. Once again, if you know the magnitude of first vector, if you know the magnitude of this vector, and if you know the magnitude of this vector, then you know the and also the angle theta between those two vectors, then you know the magnitude of resultant. But when you say vector, then knowing magnitude is not enough. We would like to know the direction between the resultant and the first vector. Let's say that phi is the angle between resultant and first vector p. Let's draw a line. And as we have observed, if this is q, then, and if this angle is theta, it is a parallelogram, so parallel side they will subtend same angle. If this angle is theta, then this also has to be theta. Then this perpendicular that we have drawn must be q sine theta. And what about base? This base must be equal to q cos theta. Now can we determine tan phi? Yes, by geometry tan phi must be equal to q sine theta divided by this length. And this length is nothing but p plus q cos theta. So tan phi is given by tan phi equal to the perpendicular by base. Perpendicular, we have observed it to be q sine theta, and base is p plus q cos theta. Perpendicular, we have observed it to be q sine theta, and base we have observed it to be p plus q cos theta. So that gives the angle between resultant and P, phi equal to tan inverse q sine theta divided by P plus q cos theta.